Hello, Accelerated Math 6-7 students. We are working in Module 8, and this is going to be Lesson 6. And Lesson 6 is called Rational Numbers and Division. Okay, Rational Numbers and Division. Today we are going to practice converting decimals and fractions by incorporating long division. The question that I want you to be thinking about is what kind of equivalent fraction makes converting a fraction into a decimal easiest? All right, so some things to remember because you guys, believe it or not, learned division quite a long time ago. And one of the tools that you used when you were taught division is the place value chart. So place value is the key. The first question that I want you to thinking about is, what is the value of this number? Okay, and so we're looking at this one right here. And if everybody can see it, you can see that the value of this says 1 and 33 thousandths. Okay, if you don't know, make a place value chart and put it in. Okay, so here's our place value chart. Tens, ones, decimal point, tenths, hundredths, thousandths, 10,000ths. And then we line up the decimal point the way it is up here, and we put it in. So this would be read mathematically, 1 and 33 thousandths. Okay, and that's how you read it. Okay, so now we know that that number is 1 and 33 thousandths. How do you write it as a mixed number? So the first thing that we have to think about is say it out loud. 1 and 33 thousandths. Okay, and so if we write exactly what we say, we have 1 and 33 thousandths. All right, so then the next question that it asks you is, how do you write it as a fraction? And what I'm talking about as a fraction is that we're not going to have a mixed number anymore. And so some of you have learned this to be called an improper fraction, or I've been saying a lot this year, a fraction greater than 1. And the reason why we're saying a fraction greater than 1 is because you have 1 and something else. So it truly is a fraction that is greater than 1. And the other thing that we've been working on as of late is you take the denominator and you draw one whole, but we don't want to draw one whole that has 1,000 spaces. So we have to figure out a different way to do it. And so what we do is we say, okay, one whole means that there are 1,000 spaces filled in. And then we have another whole, but not all of them are filled in. Only 33 of them are filled in. So one of them, 1,000 are filled in. And in the next one, only 33 are filled in. And so that number really is 1,033. Okay? And then we have to remember that our denominator never changes, and so it's divided by 1,000. So this is how you write this whole number up here as a fraction, okay, or an improper fraction or a fraction greater than 1. So it went from 1 and 33 thousandths to 1,033 thousandths, okay? So hopefully that's making sense to you and you're starting to see it. It says, what is a tool you can use to convert a decimal into a fraction? And so something that you need to think about of converting a decimal into a fraction is using the place value chart, okay? Because the place value chart helps you to see the words that correlate with the numerical values, okay? And so the next thing that I need you to do is converting fractions to decimals. So now we're going to work backwards, all right? And this can be a tad more difficult, and there are a few steps that we need to remember, okay? And so going to the next page, a few steps that we need to follow that makes the process easier, okay? Because we're mathematicians and we're always looking for ways that make things easier. And so step number 1, I'll wait for it to focus, come on. Focus it up, there we go. Okay, step number 1 is, first of all, you need to identify the denominator. Step 2 is you need to determine if it has a multiple of a base 10. And so what we're talking about, if you remember about a place value chart, every time you move to a new column, it has you multiplying it by 10. So that's what I mean by a base 10. So you look at the denominator and you say, oh, can this denominator go into some 10 evenly? All right, and so that's something we're talking about is if we have a multiple of a base 10. Then it says create an equivalent fraction with the base 10 denominator. And then you read it out loud and you write what you say. Now, some of you there going, oh my gosh, this is so crazy. It's really not when you actually try it. So let's try this one right here. Let's say our fraction is 3/4. Okay, and so we ask ourselves, is 4 a factor of a base 10 number? Well, the answer to that directly is no. We do know that 4 goes into 20, but 20 is not base 10 because we don't move over on the place value chart by 20s. We move over on the place value chart by 10s. But we do know that 4 goes into 20 evenly. So the first step is we're going to take 20 times or 4 times 5 to get 20, and we're going to take 3 times 5 because what you do to one side you have to do to the other. And so now we know that this fraction is equal to this fraction, 15/20. Well, now you ask yourself, does 20 is it a factor of a base 10? And the answer is yes, because 100 is a base 10. It goes ones, tens, hundreds, thousands. So 100 is a base 10. And so then you ask yourself, how did you get from 20 to 100? Oh, that's easy. We multiplied by 5. What you do to one side, you have to do to the other, and 15 times 5 is 75. Okay? Now, all it says after you have the base 10 denominator is read it out loud, 75 hundredths, and now you write what you say. So we have 0, because we don't have a whole number, and 75 hundredths. We just converted it to a decimal. Okay? So we started out with 3/4, and we wrote it as a decimal being 0 and 75 hundredths because we found that it could be changed into an equivalent fraction that has a base of 10. Okay? All right, so now it's your turn to try it. There's 2 problems. So again, if you follow the steps, first thing that we do is we identify the denominator. The denominator is 5. This one's a lot easier. Okay? The next step is to decide if it is a factor of base 10. That answer's pretty easy. I see that you can do it. Hopefully you can figure that one out. I'm going to make you do it by yourself because I don't need to tell you. All right, and then this one, 3/40. Again, you do the same process. Is 40 a factor of a base 10? The answer is no, right? But can we get there? Yes. Can we get there again? Yes, until you get to an answer that has a base 10 denominator, and then you write what you say. So I want you to try those 2 without me. If it gets too tricky, we'll go over it in class. Okay? So that's one way of turning a fraction into a decimal. All right. The other thing that we need to keep in mind when we're working with this is sometimes we can get confused because there's different types of decimals. The type of decimal can determine if you can find a base 10 denominator. If you can't, then it's usually because they are repeating. If you can, then they usually are terminating. So the types of denominators that we have are terminating or repeating. Terminating decimals are a decimal that stop. That means if you keep finding an equivalent fraction long enough, you will find the base 10 that works. Okay? But if you don't keep going, then you might not find it, number one. Because if it terminates and it stops, that means you can find the denominator because the number itself will stop and be complete. And so you just have to find where it stops, and that tells you what your base 10 denominator is. Some examples of this are 0 and 25 hundredths. Well, if you read that out loud, 0 and 25 hundredths, right there, it stopped. And we found the denominator, which was 100. Okay, so now let's read this one. 5 and 125 thousandths. So this one would be 5 and 125 thousandths. So again, you found the denominator because it stopped. Okay, and then the last one, 1 and 875 thousandths. So again, we found the denominator because the number stopped. So that's why terminating decimals are pretty simple. You just have to figure out where it stops and read it out loud and write what you say. Repeating decimals, on the other hand, are not so easy. Okay? Repeating decimals are a decimal that continues with a digit or digits that repeat forever. And so the key to figuring out these guys is you just have to try to do some kind of memorization of what what they call benchmark fractions. And when you see them, you just need to train your brain. If you see one of these, you have to memorize that it equals something, okay? And the only other thing that I would say that you could try is to come up with a division problem that would tell you. But the tricky part about that is you can't find a denominator with a repeater, all right? Because we don't know where this 3 is ever going to stop, so we can't ever locate the denominator. And so it's really hard to try to figure out it a different way. So for you guys, I just really need you to start getting this idea that you need to memorize what it is. So when you see 0.3 repeating, this fraction, because it's a benchmark fraction, is 1/3. So whenever you see this decimal, that means it's 3 forever, you need to know that it's 1/3. If you see this one, then this one is 2/3. Okay? And then again, we talked about understanding what this one might be. Well, since it's 2 digits repeating, you know that the denominator has to be 11, right? And so if you think about it that way, you might think of it as this being 1/11, okay? Because what you're envisioning is 1 divided by 11. I don't know if that would work, actually. So we'll have to play with it and see. But again, you need to memorize these as being fractions that you just have to try to play around with on the calculator until you find them, okay? And so repeating decimals, basically the thing that I need you to know about repeating decimals is that this bar is telling that this combination of digits is going to repeat forever. This bar being over these two, it means that 45 is going to repeat forever. This bar being over the 3 means the 3 will repeat forever. This bar over the 6 means this 6 will repeat forever. So the repeating bar is a symbol used to show that the digit repeats forever. Okay, one last thing that I have to cover with repeating decimals is that sometimes you're going to see an example like this. And this is 0.83, and notice that the bar is only sitting over the 3, so the 3 is the only number that repeats forever. So you have to really pay attention to that repeating bar telling you what exactly it looks like. The repeating bar sits over only the digit or digits that repeat. So this one would look like, if you saw it on a calculator, it would look like this, because the bar is only sitting on the 3 and it will go forever, okay? So that one is what that means. So again, trying to figure out the fractions that represent them. Some of them you just have to memorize because it's really hard to figure out what the denominator would be. All right, so the moral of this lesson is you have to know that there are 2 types of decimals, okay? And then the last thing that we can do if we absolutely can't figure out what the decimal representation of a number is because we can't find the base 10 denominator, if the denominator cannot be converted to a base 10 denominator, then you treat the fraction as a division problem. So an example of this, 9 will never, ever, ever convert to a base 10. It just won't. And so what we have to do when it won't is that you have to read it like a division problem. So this says -4 divided by 9. So it says 9 does not have a multiple of 10 base 10. So we have to write it as a division problem. So it would be -4 divided by 9. Okay? And so if you look at it, this is the way you would write it, is you would say -4 divided by 9, and then automatically your brain should be seeing that you're doing some long division, and that long division will turn into a decimal. Okay? All right, kiddos. Lots of information about turning fractions into decimals and decimals into fractions. So let's go back to our goal, rational numbers and division. Today we are going to practice converting decimals and fractions by incorporating long division, which I just showed you. Okay? The question that I want you to think about is what kind of equivalent fraction makes converting a fraction into a decimal the easiest, and what that equivalent fraction needs to be is anything with a denominator of 100 or 10. Okay, so a base 10 denominator. All right, kiddos, that's all I have for you today. I'll talk to you soon. Bye.